trigonometry, and solving right triangles. What do we need to know in order to solve the triangle? Well, the first thing we have to do is label our triangle. We have to use capital letters for angles, lowercase letters for sides, and we have to remember that side A is always opposite angle A. So we can create a diagram. Angle A is up here, side A directly across. We also need to remember we can use the Pythagorean theorem to solve a triangle. And remember, the important part with the Pythagorean theorem is that the hypotenuse, the side that stands alone in the equation, is opposite the right angle. Okay. We also need to remember our primary trig ratios, and we need to remember the hypotenuse never changes location. Theta, opposite angle theta, draw a line to the opposite side. The angle theta is made up of these two sides. One is the hypotenuse, the other side will be the side that's adjacent to theta. If I look at the other angle, phi, that's opposite phi. This angle here is made up of the hypotenuse and this side here, so that side is adjacent to phi. The primary trig ratios are sine theta, where sine is opposite over hypotenuse, cosine theta, where cosine is the adjacent side over the hypotenuse, and tangent, opposite side divided by the adjacent side. And we have a memory aid, SOHCAHTOA, to help us remember those three ratios. Now remember, those three ratios can only be used if we have a right triangle. If we don't have a right triangle, we can't do it. Example 1 wants us to solve triangle DEF, and it tells me angle FED is 90 degrees. So I'm going to start by drawing a right triangle. Okay. Probably should highlight what I know. I'm solving the triangle. It told me angle FED, it told me side D, and it told me side F. It tells me side lengths must be correct to the nearest tenth of a centimeter, angles the nearest degree. So what am I looking for? I'm looking to solve it. Side length, I need nearest tenth of a centimeter, angles to the nearest degree. Okay, so let's go back to my diagram that I started. Angle E is in the middle here. So that means angle E is going to be the 90-degree angle. It doesn't matter where I put side or angle D and angle F. Okay? If I read this, angle D, E, F, E was in the middle, and that's the angle I'm referring to. Side D, angle D is here, so go across. Side D is over there, and D is 6 centimeters. Angle F is here, go across from it to the opposite side, and side F is 7 centimeters. Now that diagram is pretty messy now because I've drawn arrows all over the place, but that's okay. I want to solve the triangle. I know two sides in a right triangle. What should I be using to solve that? Do I have to use trig? Do I know any angles? It doesn't make sense to use trig. It does make sense to use the Pythagorean theorem. Now if I look for my right angle, that's my right angle. The side I don't know is the hypotenuse. So it stands alone on the left side of the equal sign, and I substitute in the side lengths of the other two sides into the equation. So I've got 7 squared plus 6 squared. E squared is 49 plus 36, and E is 85, and E is equal to the square root of 85. Which I don't actually know the value of right now. Let's get a calculator out. And I can't find the square root button on here. Well, that's interesting. We're just going to cheat and go to the next page. I know it's about 9.3 or 9.1. I can't remember. We've got a lovely triangle here. See how much prettier it is for you to copy? Okay, and there is the answer. I was close, 9.2. Okay, so once I have that, it's said to the nearest tenth. We can go back to our blank screen here. And E is around 9.2, and I need to have my units, which is centimeters. I have one side. What do I need to solve for? I can choose to solve for angle D or angle F. Does it matter? Not really. If I choose to solve for angle D, I know my opposite side, and I also know my adjacent side. So I have to think about what trig ratio uses opposite and adjacent. And that's tangent. So the tan of angle D is equal to the opposite side over the adjacent side. So in this case, tan of D is opposite, which is 6 over 7. And that means D is equal to the inverse tan of 6 over 7. So again, I can get my handy dandy calculator out, and hopefully I solve for angle D in this so I have the answer. I did. Once I get my handy dandy calculator out, it's 40.60 blah blah blah. Notice I've put a dot above my equal signs because I've rounded. Notice I've got D equals everywhere because I solved for D. Once I started using the calculator and did the shift tan on my calculator, I was only solving for angle D. So D is 41 degrees. Now the easiest thing to think about is, let's see, if I go back to this triangle, I know the length of side E, I know this is 41 degrees, I know that's 90 degrees, and the angles in a triangle have to add to be 180 degrees. So if I just add them up and solve the equation, angle F is 49. So I did the 41 plus 90 plus the unknown angle is 180. And I put the dot here. And the reason I put the dot there is because 41 is a rounded answer. So I do need to put that in there to show that it's not exact. And therefore, angle F will not be exact, and it's an approximate answer. And before class tomorrow, finish off exercise 1, page 4, number 6 and 7.